So now we'll discuss about the stack ADT. So stack ADT is a linear data structure that follows last in first out principle. So that means it shows the element of a limited size. That it has only one end where Q has two ends, that is front and rear. So it contains only one pointer, top pointer, pointing the topmost element of the stack. So in other words, stack can be defined as a container in which insertion and deletion can be done from one end known as top of the stack. So here is, you can see here, so pushing 1, pushing 2, pushing 3 values, pushing 4, pushing 5. So it will be in a order. Operations of stack. So the main operations is push, pop, is empty, is full, peak, count, change, display. So pushing means inserting the element, popping means deleting element, empty means we have to check whether the stack is empty or not. Full means we have to check the stack is full or not. Peak, it returns the element at a given position. Count, it returns the total number of elements available in a stack. And change, that is, it changes the element at the given position. Display means the elements will display, print the elements available in the stack. Push operation. So before inserting an element in a stack, we check whether the stack is full. So if we try to insert the element in a stack and if stack is full, then overflow condition will occur. So when we initialize the stack, we set the value of top as -1. So when new element is pushed in a stack first, the value of top will be incremented and top equal to top plus 1. So it will give the new position to the top. So the elements will be inserted until we reach the maximum size of the stack. So here we can see first it will be empty, that is top -1, top 0, pushed, push 20, push 30, push 40. So the top size is 3, the stack is full. Next is pop operation, that is deleting. So if stack is not empty, we first access the element which is pointed by the top, and once the pop operation is performed, the top is decremented by 1, top equal to top -1. So if stack is full, we have to pop each element 40, 30, 20, 10, so till the stack becomes empty. Implementation of stack. Stack can be easily implemented using array or linked list. So arrays are big but are limited in size, and linked list requires overhead to allocate link, but it's not limited in size. So adding an element into the stack, that is push operation. So here implementation of push operation in C language is given here. So we have to check if top equal to that particular value, particular size n. If it is overflow, then it will else it will increment, that is top equal to top plus 1, and it will add the value. So that is the push operation. And pop operation, so we have already seen that deletion of the values, pop operation. Implementation of pop in C languages. So we have to see that top equal to -1, and if it is underflow, it will print underflow. If it is not, it will decrement that top minus. Visiting each element of the stack, that is peak operation. So int peak, that is it involves returning the element which is present at the top of the stack. So it also check whether it is underflow condition, otherwise it will return the stack at the top value. Next is the linked list implementation of stack. So here a linked list allocates the memory dynamically. So the time complexity in both scenarios is same for all operations, that is push, pop and peak. And each node contains a pointer to the immediate successor node of the stack. So here you can see each node is connected with each successor, that is immediate successor node. So it is said to be overflow if the space left in the memory heap is not enough to create a node, and topmost node in the stack always contains null in its address field. Adding a node to a stack, that is push operation. So here adding a node to a stack is referred to as a push operation, that is creating a first node first and allocate the memory to it. So if the list is empty, then item will be pushed to start node of the list. So if there are some nodes in the list already, then add a new element in the beginning of the list. Likewise, assign the address of the starting element to the address field of the new node and make a new node and starting node of the list. Deleting node from the stack, that is also like pop operation. So check for the underflow condition, and we try to pop from the empty stack, already empty stack, and adjusting the head pointer accordingly. So the next node of the head node now becomes the head node. Applications of stack, that is the stack is widely used linear data structure in modern computers, and in which insertion and deletion operations of the element can occur at only one end. So main applications is balancing symbols, backtracking, reversing a data, processing function calls, evaluation of arithmetic expressions. In all these things, stacks stack is very much useful. So evaluating of arithmetic expressions, that is one of the applications. So here we can see the infix, prefix and postfix notations. So infix means, so it is a convenient way of writing expressions, that is in which each operator is placed between the operands. So we can see the example. So a plus b, c minus d. So all these expressions are infix because the operator comes between the operands. Prefix, that is the prefix notations place the operator before the operands. So plus AB, minus CD. So all these expressions are prefix notation because the operator comes before the operands. Postfix notation, that is the postfix notation places the operator after the operands. So that is AB plus CD plus. So all these expressions in the postfix notation comes because the operator comes after the operands. So for example, we can consider that is infix expression 2 into 4 open braces 4 plus 3 close braces minus 5. So here we can see this is a postfix expression. So here we can evaluate using the stack, that is stack is empty, then we have to move 2, 4, 3, next is the plus symbol. So we have to add all this, so totally 7, 2, 4 plus 3 7, and next is the multiplication symbol. So 7 into 2, that is 14, and next is the 5 value we have to insert in the stack, and then minus, so 14 minus 5 is 9, so the final value is 9. Balancing symbols. So balancing symbols means we have to check whether the expression is balanced. So first case we can see a plus b is in close braces plus c minus d is in close braces. So this is the expression is having balanced symbol. Second case, if we see a plus b is having as close braces and c minus d is having a close braces, and one open braces is at the starting, but the braces is not closed. So one close braces is missing. So this is not balanced. So likewise, you have to check the balancing symbol.